So this video is going to be pretty short because all we're going to have to do is use a half angle formula to find out a tangent value, which will be fairly straightforward. So I'm not given, you know, I'm not given a tangent or sine or cosine of theta. I just asked for this value. What is it? So it's different from the previous video in that this thing I need to think of. Well, 7 pi over 8 is not a common angle that we have memorized. So I need to think of this as being half of something, right? So what would 7 pi over 8 be half of? Well, it's half of 7 pi over 4. 7 pi over 4 over 2, that's the same as 7 pi over 8, right? So this top guy, this is the theta I'm going to be working with when I use the half angle formula. Okay? So tangent of, and I'll write it like this even though maybe it's not really necessary, 7 pi over 4 over 2. Well, this is going to be sine of, and if you look back at your formula sheet, sine theta over 1 plus cosine theta. So this is sine of 7 pi over 4 over, fix that 4 a little bit, over 1 plus cosine of 7 pi over 4. Okay, if we draw a quick unit circle, we can illustrate where that's located. So 7 pi over 4. One way I like to do this, when in doubt, is I like to cut these into quarters and then number them. After you've done this enough, you don't really need to do this. But to get started, I can say, oh, this is 0 pi over 4 chunks. This is 1 pi over 4, 2 pi over 4, which of course is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. 7 pi over 4 is there in quadrant 4, right? So I know, because I'm dealing with a multiple of pi over 4, that sine and cosine will both be root 2 over 2, but plus or minus root 2 over 2, right? Since I'm in quadrant 4, I know that sine is negative, cosine is positive. So I know that this is negative root 2. Write that a little bit better. Negative root 2 over 2 over 1 plus root 2 over 2. And I don't like having these stacked fractions or nested fractions, or have fractions inside of fractions. So I'm going to multiply top and bottom of this larger fraction by 2, because when I distribute, this 2 will end up reducing this root 2 over 2 to just root 2 as well. This 2 will reduce this into just root 2, right? Because you take half of something and double it, you get what the numerator says. So this will be negative root 2 over 1 plus root 2. And we can basically leave it there. If we really want to, we can rationalize the denominator by using the conjugate. Let's go ahead and do that, although it's not essential. It doesn't hurt. See how that goes. This is a concept we need to use sometimes, and it's something that you're going to need to use in Cal 1. So I'm going to use the conjugate of the denominator, so 1 minus root 2. And what conjugates mean, we'll get more detail on later when we talk about complex numbers, but for now it just means you have a whole number plus or minus some radical, some root, square root, cube root, and so forth. The conjugate just means change the sign between them. That's all it really means. Again, we'll get more detail on that later. So when I multiply in the numerator, when I distribute, well, let's do it this way. Let's say I have negative root 2 times 1 minus root 2. Let's be a little more explicit and not leave steps out. And 1 plus root 2 times 1 minus root 2. Okay. So in the numerator, I'm going to have a negative root 2 plus, think about what root 2 times root 2 is. It's 2, right? You might think about root 4, but that's really not essential. Maybe I can make another video explaining why when I see root 2 times root 2, I do not even think about 4. Not that that's wrong. This is equivalent to the square root of 4, but you don't need that. So if you'd like to see more detail on why, make a comment or send me an email. Anyway, when I FOIL the bottom, the denominator, I'm going to end up multiplying, so first, the two first elements, so 1 times 1, then the two outer elements, so 1 times negative root 2, the two inner elements, root 2 times 1, and then the two last elements, root 2 times negative root 2. So I'll end up with 1 minus root 2 plus root 2 minus 2. Okay, so these two root 2's will cancel, negative root 2 plus root 2. What does not work is a somewhat common mistake is to try to cancel these 2's. That doesn't work. That's not how cancellation in a fraction works. If you're unclear on that, send me an email, post a comment, and I can give more detail. So what do we get? Well, I'm going to get, running into the next example, I'm going to get negative root 2 plus 2 all over, well, the new denominator is negative 1. So I can then divide each term in the numerator by negative 1, and I'll get root 2 minus 2. So this is a little bit cleaner than what we had a few minutes ago, if I can zoom out here. So we had gotten, what was it, this guy, negative root 2 over 1 plus root 2, which is fine, that's okay. But by rationalizing the denominator, we did get a nicer looking number. Root 2 minus 2 is just a little bit cleaner. It's not a fraction, basically. Anyway, that's how you can use the half angle formula for tangent to find out an exact value.